welcome. I said today is September 13th, 2 p.m. Central European time. And I have the honor and pleasure to welcome you to the fourth webinar of the second series. And I'm speaking here today live from Munich. So later on, we have also the possibility for sure to have a Q&A, but I come to these details later on. And I will introduce you now a good day, morning or afternoon, evening, wherever you are located and joining our webinar to introduce our two panelists today. So a warm welcome to our experts, Kurt Essigmann from Ericsson. He's live here from Aachen, Germany. And we have Dr. Joachim Walewski from Siemens on the other side, representing also the OT side, live also from Munich, from Germany. So warm welcome, and with this I would hand over then to Kurt to start with the details. Thank you very much.
Thanks, Uwe, for a nice introduction. So this web session is all about presenting the content, but also to give some background on the 5G-ACIA white paper that we have published on the exposure capabilities. And published means that this has just been published in the spring of this year, 2021. So my name is Kurt Essigmann. I work for Ericsson, and I will talk together with Joachim Walewski about how industrial applications can use the 5G services. So the intention of this webinar, this session, is that you will understand in the end how your applications not only can benefit from the high reliable and low latency communications of the 5G system, but basically also how you can control and how you can steer, in fact, operate the 5G services. So we will use roughly this agenda in this webinar, and of course, in the end, you can ask your questions. We will give a bit of an introduction. We will see then how 5G connectivity for automation networks will look in reality, how exposure interface architecture is expected to be done. We will go in detail, not in detail, but we will look at the detailed use cases and, of course, give you an outlook as well. So this white paper that we are presenting to you today is, of course, still rather new. It has just been published before the Hanover Fair, so this year in February, March. And it has been actually produced in its second version. The first version was published before, and now we have a refined second version that we will introduce to you. And the reason for us to work on this subject at all in 5G-ACIA is that there's a clear expectations from the industrial application that they would like to manage their connectivity. They would like to manage the way how devices use the radio connectivity. And if I say applications, I mean, in fact, both engineers developing the applications, but also system integrators. So all of that, of course, needs to be possible, and these are key principles. All of that needs to be possible without really understanding 5G in detail, because industrial application developers are not 5G experts, but they are, of course, application experts and, of course, have a very good IT knowledge. That's why all this exposure must be in an IT style. What the white paper contains is mainly two groups of use cases. The first group is device-related use cases, how to manage individual devices. The second group is more related to network use cases. We will go into this group a bit later on in the webinar. And at the end of the white paper, you will find a very detailed operational use case description. Those may be interested for you if you really want to specify APIs or if you want to implement them. But now, before we dig into the details of how the exposure look like and what the interfaces are, we would of course like to first of all understand a bit from which regions do you guys in this webinar are from, and also from which kind of stakeholders are you coming? Is it academia or is it more the industrial OT part, more the ICT part, or if it is others? think depending on what your background is, of course. So please click on this multiple choice, so we can have a bit of an overview where you're coming from. Depending on the distribution of people, of course, it depends pretty much on what kind of earlier experience you may have with both 5G, but also with the exposure interfaces and with the expectations that if you're coming from an OT domain, of what expectations you would have towards a 5G network, what this network is expected to give to you. So now we have the results. So that looks, of course, quite interesting. We have the majority of the people coming from the ICT industry, but we also have something like 25%, a quarter of the people from the OT and academia. So that's a very positive sign. We have 9% of others. So there we have to capture also in the next webinars, maybe a bit other, let's say, groups where you're coming from. So we have lots of ICT people. Good. It's also a very ICT focused webinar. And then we could also try to look at the second question where we'd like to know from which regions are you from? And there I would like to ask then my colleague to bring in that question. You see here we have the different continents where we usually had a quite high dominance from Asia and Europe. And of course, we're interested to see if this time we have managed to also being able to attract maybe people from other continents, despite of the time of the day. That is, of course, for some continents, not so optimal. Yeah, so here we see the results. We're having, of course, the majority of the people from Europe because it's early afternoon in Europe, so very convenient. We also have some representatives from North America. We have 21% representatives from Asia. We have unfortunately no representative from Africa, and that is actually what we were hoping for, to get also some colleagues from Africa involved. But that is this time not the case. But okay, so we see that we have basically Asia, North America, and Europe in the call. So thank you very much for indicating to us where you're coming from. Thanks a lot. And then before we are digging into the actual exposure use cases and the architecture of the exposure, I would like to ask Joachim Walewski to come in and explain a bit how 5G is actually today and in future integrated with automation networks. Joachim, please.
Thank you, Kurt. So if I could get the next slide. Yeah, thank you. So this is quite a busy picture, and I will take you through this step by step. So there are two things that are really important when you think about 5G in industrial production. One of them is this network that we are kind of depicting here is limited also not only like in on the slide, but also geographically. Typically, 5G networks will be non-public networks, so only accessible to the devices that belong to the factory, and will also be geographically constrained to the campus of where the factory is. So that's the first thing that this picture implies. Also, what it implies is that there are a lot of connection topology. So questions of where the data goes from what device to what device through what network. That is quite complex, and that's also this is a very simplified picture already, what you see here, but I will try to bring it through. So in the core is the 5G non-public network here, and the 5G exposure producer, that is something that then Kurt will talk about. But let's say, just like in the beginning, what do we see? We see that on the left-hand side, in the production domain, we will have UEs, user equipment, so the 5G transceiver. And that is done normally tandem up with an industrial IoT application, so IoT application, and therefore my integrated device. So let me start with that. So what we could have here is, for example, an actuator or a sensor, and that wants now to communicate with a controller. Controllers are often then connected to the 5G network via cable. So this is what you see on the right. This is the of the network. There's this IoT application sitting on the enterprise IT network. And then the blue line indicates a wired connection. And important here, enterprise IT network can be different networks actually, depending on where we are on the picture. What it is, it's a placeholder for saying it's not the 3GPP connection, but it can be industrial Ethernet. In some cases, could even be like an old-fashioned bus, or it could also be standard Ethernet. So these are the typical communication protocols we would see enacted here. So this is one interaction here, but then there are many more. There are, for example, also controller to enterprise applications. So, for example, we have a controller that is interfacing with a UE and wants to go and connect to enterprise application, which are in the enterprise domain on the right. So that's also typically one. So that's not, this kind of leaves in the production domain and goes a little bit further, but it's still on premise typically. And then in the end, we have controller to controller. How could this look like? So if you look in the left-hand corner, there's something is called IOGW device. That's the gateway device. So here, what is interesting is that the integrated device, actually the device, for example, is a robot, and it has an onboard cabled network. So the enterprise IT network here, for example, could be IEEE TSN, and the applications on the robot will communicate with it. And then there is this modem type of 5G user equipment that then allows this robot also to communicate with, for example, peers, other robots, but also the enterprise system and so on. And when I talk to peers, then often what's going on, not every sensor in a robot is talking to the other, but rather the controller of one robot talks to the controller of the other. So what we also see here is something you know also from typical daily use when you use your smartphone, when you call somebody, we will have this also for data traffic here. So you can see here already, the network is more complicated than this rather simplified server client model, which you had in the past for 5G networks. Also, that the devices themselves have their own network. So applications don't necessarily kind of sit directly on the user equipment itself. So how does this help us now to understand where the study is coming from? For this, I would like the next slide. And there is not only do these devices have rather complex interaction methods, but if you maybe have noticed, I've not talked about a single human so far, because a lot of the devices in the factory talk to each other without any human being involved in it. So there is a lot of machine type communication, machine talking to machine. And also what not only do they communicate with each other, but also because devices become more autonomous, you could say, they will also do a lot of the configuration and becoming, dialing into the network, becoming getting connectivity. That will be done by the devices themselves. So this whole topic of device provisioning, so which here also means the provisioning of the UE, together with all the applications, the onboarding on the network, also offboarding, for example, at the end of a shift, that will be done by the machines themselves. Also, what is from an enterprise perspective is really interesting is that the enterprise side, for example, has as you saw before, an MES, a manufacturing execution system, and that could control entire groups, because normally we don't have just like a single UE, but we have a lot of UEs that belong to devices who work together to produce something, for example, in a production cell. So, and instead of managing all of them individually, what is also really needed will be then that the enterprise system can manage these in groups. Now, what is also very, very important is that in the more like telecom applications, you can define like 3 or 4 types of communication and cover quite a bit. In industries, unfortunately, the variety is much bigger. So the range is large of what quality of service you want to have. So sometimes you don't need any. It's best for just good enough. But then on the more extreme side, we have like extreme availabilities we need, very short latencies, and so on. And all of this also has to be not only be provided by the network, but it has also to be it has to be we have to be able to instantiate it either from the enterprise side or often also from the device side in the production system, so that it can configure this. And when I am also then look at the next point, cost monitoring, what is this all about? Well, we know that you can monitor the traffic in a system. So if this is a 5G system that belongs to a factory, you could just like log in with the monitoring interface and look at this. But what is new is that, for example, that the robots I talked about, coordinate with each other, they might be interested in actually monitoring their own traffic, but also the traffic of the cohort. So how is it going? So, for example, if they don't hear from their peers, their robot peers, why is that? Is that because they broke, or is it because the communication doesn't work? So this is also something you also has to be configurable from either side, the enterprise side or the production side. What is more is we already see the dawn of many more services in 5G. The first candidate here to mention is, of course, localization. That's a service we also want to access. So the exposure will not only be communication, will be localization and whatever is in the future of 5G. And the last one is really important, and that ties a little bit over to what also Kurt will talk about. I said, like, mostly we think that these networks will be on location with the dedicated hardware, and they will be enclosed. But that will that's a rather German centric way of viewing things, because in other countries will actually show that while there will be network hardware on the location, the network itself will be a virtual as a part of a virtual network within a operator network, so a public network, if you want to see it this way. And what we then have is that since we are now only part of the network, then we don't have full access to all the monitoring information, but the operator still wants to know how is this slice of the 5G network actually working. And so what another exposure that will be really crucial for getting this working is that the user of the this network can monitor the network itself, not in its full breadth and all the details that, of course, the operator of the public networks has, but a subset of these functionalities. And so we have now I've motivated this, why we are interested in this, and then I wanted to hand over soon to Kurt, but before that, there is another question we would like to ask, and that is, I've talked a lot about 5G devices in factories. So we are interested, if you think of your company or also your research institute spin-off, whatever it is, and you think of the industrial products that you may be offering, are you already planning to have them equipped with 5G user equipment? Maybe you already have products. Do you do it next year, 23? Is it 24, 25? Or haven't you made up your mind yet? So yeah, now I can see. Okay, so this is really interesting because the majority, well, 50% either already it does have products or has it like in a really near future. And that is really interesting because 5G is an evolving technology. We just like on the cusp for seeing the next release. So I'm actually quite fascinated by this result, and don't know. Yeah, well, that's also good because a lot of people want to know more about 5G also for production, and that's why they're here. So I hope we really can help you a little bit with getting a better grasp of it. And then the minority says like in the further future, 2024, 25, but from an OT's perspective, actually 2024 is not that far into the future as it would be for ICT. And I mentioned ICT, so I think now it's time to hand over to Kurt to talk a little bit more about the requirements we came up and how the whole philosophy of the exposure actually looks like. Thank you.
Yeah, thanks, Joachim, for explaining a bit how actually 5G will be used for which devices and for which use cases on the control plane. So now since we have understood that, I would like to move to the next slide, and we can have a bit of a look at how these exposure capabilities can in fact be accessed. So in this figure, we have roughly three reference points that I would like to point out, and I'm trying to get here a laser pointer to show at them. So we have on the left-hand side the so-called reference point ED, that's the device side. So that's a reference point for applications, industrial IoT applications residing on the device to access the capabilities. We also have the EN reference point, and that is the reference point where industrial IoT applications on the enterprise domain can access the exposure. And we have the NM reference point that is then basically between the service provider and the enterprise IoT applications. So no matter in which case this application sits, so in case of the application sitting on the IT enterprise domain, as we heard, it could be a ERP MES system that is 5G aware. No matter where they sit, as soon as they have IP connectivity and as soon as they have been authenticated towards the 5G network, these applications can consume the services exposed by the 5G network. So if, for instance, you have an mobile controller integrated device or a gateway device that has some logic implemented, that logic could ask basically, for instance, to change the quality of service or to set up a new device connection with a certain quality of service. The same can be done from this IoT device on the network side, on the IT enterprise domain. It can again request for a device a certain quality of service connection, but it can also do that in a bulk for a whole group of devices if they have similar requirements and similar characteristics. A bit of a difference is if the NM interface is deployed, because this reference point will be needed for more network-centric kind of applications, well, use cases, in fact, in order to do complex network management tasks. And not all of these network management tasks will be available for the enterprises, because that pretty much depends how these networks are deployed, who operates them, who runs them, and what effect it might have on the network or even on other enterprises. And why that is important, and to better understand how this situation looked like, I would like to go to the next slide and do a bit of a recap of what we have published before in a 5G-ACIA white paper on private networks. So here you see two different network deployments. On the left side, we have depicted a standalone private network. The terminology for that one, according to 3GPP, is SNPN, so standalone non-public networks. This is a self-contained network where you have all the network elements and all the network functions on the enterprise premises. So this network can run completely independent of the outer world. It has the advantage that, of course, all the network management functions can be executed by one single party, for instance, the enterprise, or by the service provider who operates the network on behalf of the enterprise. But of course, whoever operates this network, he must have the right competence in place. He must understand exactly how to operate such a network. On the right side, we see a deployment option where for instance, a mobile network operator deploys the network. And in this case, not all of the network elements and network functions must be on premises. They can also be off premises. And some of the elements are shared. For instance, the radio network is shared. So you can access both specific enterprise services, but you can also access services that are deployed and operated, provisioned by the public operator. The abbreviation for this right-hand side picture is called the PNI-NPN. So it's the public network integrated non-public network. So it's when a mobile operator basically provides you a network or a network slice. In that case, the mobile operator will basically take care of all the network management system, will lifecycle the network. But of course, if the enterprise would like to do specific use cases himself, that must be done via a mutual agreement. So that must be specified beforehand to see what the service provider will allow the enterprise to execute and what not. We will look into these network-centric use cases 2 slides further down, then you will understand why this mutual agreement has to be in place. Of course, in both cases, no matter if we have an SNPN, so a standalone NPN, or a PNI, a mobile operator provided private network, the enterprises will want to see the network status. So for the enterprises, it is important to understand if they reach certain system limits, if the network is up and running according to the specification or not. So these are 2 fundamental deployment options and 2 fundamental also commercial decisions that have to be taken in order to understand how to operate the network and how to operate devices. And since this is so fundamental, we of course would also be interested to ask you basically the last question this webinar in this webinar, and where we would like to understand if you intend to use for your operations more the standalone or the mobile network operator provided networks. So for that one, we have also opened a multiple choice where you can select the different options. So I do not yet see now it's coming up. So here again, you can select whether you think that for your operations, for your factory or for your enterprises, you would like to have a completely self-contained SNPN running possibly even on your own frequencies, depending if the country you're operating in allows dedicated frequencies, dedicated spectrum. Some countries do not allow that. Or if you think rather that a network provider should come and operate a network for you, then you don't have the burden to do it yourself, but you might have, of course, less flexibility in operating and maintaining the network. I do not see the results yet. Okay, now we're in. So we have, most of the people who have an opinion, they think that SNPNs is that what they go for. 31% want a self-contained network. 22% favor an operator provided network, and still some just over 35%, 38% have not made up their mind yet. If you need to know more information about the pros and cons and about the benefits that an SNPN or a PNI-NPN may have, I would again like to divert you to the white paper that has been published by 5G-ACIA. It's free of charge for download from the 5G-ACIA webpage, not from my company webpage. Okay, thank you very much for that. So now we can have a look at those explicit use cases that we have been talking about. So as we said at the very beginning, we have in this white paper 2 major group of use cases. One is the more device-centric capabilities that are exposed by the 5G system, and the second one is the more network-centric capabilities. So let's start with the first one, the device-centric one. So interactions between the industrial IoT applications and the 5G system in principle follows a very well-known and simple request response scheme. But some use cases also require notifications. For example, when a new device is onboarded and registered on the 5G system, the 5G network will inform the application about that new device. And it will also inform the IoT application about the unique device communication identity that is used. And so with this identity, the application can always identify the respective device. Now, when that has happened, of course, then the application can start to manage the connectivity. It can request to modify the QoS settings, it can request to monitor the quality of the connection, and it can request to receive notifications, for instance, when the requested quality is not reached, or when the connection is terminated, and that can be due to various reasons. We can run out of radio coverage, or a mobile robot, an AGV, maybe has just left the company factory premises by intention or by mistake, you never know. And also these location services, they are very important and have been also specified in the white paper. These location services also have the possibility to get a certain notification when a device leaves a certain area or when it comes close to any borders that have been done. Also very important, as we have mentioned before, is group management. If you're operating many devices on your enterprise, maybe devices that are very similar or have very similar communication capabilities, you can operate them and manage them in one bulk operation. So if you have 2,000 sensors that are monitoring the pressure, you could manage them in one go. That's very important if we have scaling up of devices. Important is also to mention that all of these use cases that we have here are expected to be operated by the enterprises on their own at any point in time when they want, without involving any third party, like a service provider or an operator. They would like to do that on their own, depending on their operational model. And the second group of use cases that we also had touched shortly upon is the network-centric use cases, network-centric capabilities. So in this group of cases, we have this additional player in the field, that is the service provider. So if you have a service provider operating a network or slices of his network for different enterprises, I think it is pretty clear that the enterprise may not do whatever network reconfigurations that he would like to do. So he cannot just restart the network or restart a node. That is something that must be very clearly handshaken with the service provider beforehand, what kind of actions are needed. In terms of network monitoring, also there we need some mutual agreement with the service provider. If we do not have an SNPN, where then the enterprises can see if he's running short of certain resources, if parts of the networks are not up as expected, if there are some regular events happening that are disturbing the operation. So that is something that either he can do on his own to adhere to the agreed SLSs, SLAs, or he has to do it via the service provider, who has then to grant access to that respective information. But once this mutual agreement is in place between the enterprise and the service provider, of course, all the network statistics, all the KPI data and various statistics can of course be retrieved and can be observed and monitored by the enterprise. And similar like with the device-centric use cases, also here the idea is that the enterprise should be able to really execute these use cases without any dependability on a third party. He can do it at any point in time, any day of the week, depending on his operations. Of course, the details of the use cases are in the white paper. If you're interested, we recommend you to download it and also go into the annex where these use cases are described in greater detail than we can present them just in this webinar. But before we conclude the presentation part of this webinar and we turn to your Q&A, I would again like to ask Joachim to give a quick outlook on the 5G exposure services.
Thank you, Kurt. So the message I want to survey here is that although this is one webinar and one published white paper, there is more going on, and there's also more installed for in the future. So we already heard this was my paper was presented at the Hanover Fair, but also more importantly, there have been other activities since then in both 5G-ACIA and 3GPP. So in 5G-ACIA, we have now a paper that features many requirements, and we will now we're looking to discuss the studying how the existing 5G-ACIA functionalities, which means then like up to including release 17, can be leveraged. So we have a requirement, and can it be already addressed? Most of the time, actually, the answer will be yes, but how exactly do you do this? This is one thing we want to look at, and this is a study that's I think really crucial also for OTs, because if you think of your, for example, your Wi-Fi system, we're talking about a way more complex and but also more capable network. In 3GPP, there are certain activities. So first, it turned out that 5G-ACIA came actually up with new requirements that have no mirror now in a like there's no capability ready for it, and also there was no requirement that described the 5G-ACIA requirements. So we're doing right now, and actually led by me, there is an activity to update the normative requirement and close the gaps. And also I mentioned release 17, there had been actually already a lot of work towards making this exposure functionality ready and to use. So with then them becoming done when the release 17 is frozen next year, hopefully this will then just like also find its way then into products. And to show like that 3GPP is always in the future, the new release technical work has release 18 technical work has started, and they are right now in the midst of discussing in detail what exactly has to be studied and then later turned into normative functions, and that is right now going on in a very it's a very busy process. But this topic exposure is also one of them to be discussed. So even in release 18 there might be more, so stay tuned and always have a look also like at what's coming out of standardization. So the point I want to make here is A, this is not just a white paper, and B, also that when you hopefully rather sooner than later get your hands on release 16 equipment, some of the things we're talking about are already available there, but much more will become available than also release 17. And as I said, maybe even more than release 18. And who knows what is installed for release 19. So this concludes the presentation part, and we have time also for Q&A, but I'm not the one who's responsible for this, but I will now hand over to Uwe, who's moderating the session. Thank you.
Yes, thanks a lot, Joachim and Kurt. I think was a lot of information. And as said, we will go now in the Q&A part about this. And I think you explained already quite well what advantages 5G could have for the smart manufacturing. And as you ended with 3GPP, we have also the first question a little bit related to this, which maybe you can decide, but maybe Joachim, you start. I will read it and then you can start to answer. But Kurt, please add whenever you think you can give additional information. So let me start with the first question. So the question is, although 3GPP defines alternatives, so far 3G, 4G and 5G positioning is basically UE assisted and network based. That means the application needs to ask 5G system for the position information. And now the question, what could be the impact on latency?
Okay, Kurt, do you want to go first or shall I?
Just go ahead, Joachim.
Okay, so there's two ways to interpret this question. First, is there an impact on the latency of the communication while you do localization in the same time? And the answer is it should not. I mean, also just like because you want a localization, shouldn't just like now kind of pause your data stream. So, but probably how this was framed was also how what's latency of that information. And if you look into standards, we have quite different requirements also for different types of localization. Sometimes you want a ballpark, sometimes you want it down to the submeter. And but the answer would be also in terms of localization update and when you need this information compared to all the other periodic communication going on, localization is normally the much slower one. So in these control loops I was talking about, controller talks to devices, we are down to a millisecond and sometimes even below a millisecond, while the localization data, I don't have it really on top of my head, but we're talking usually hundreds of milliseconds. So that's my perspective. Kurt?
Yeah, thanks, Joachim. I think I also agree to that. I think positioning and gathering localization must not jeopardize the time of delivery of the user plane, so to speak. So if you have an URLLC kind of communications with even TSN interworking, then I think we cannot jeopardize the timely delivery of user packets because of positioning. On the other hand, of course, if the application would request the UE for its current position or would request a network for the position of the UE, there is, of course, a certain, let's say, transition delay of the messaging. On the other hand, the 5G system, we have also shown that we have the possibility to send notifications upstream. So the application does not have to poll constantly the location, but it will get an indication if certain conditions are met. That would, of course, reduce the impact on the let's say speedness, how fast the location can be reported back to the application. I hope this answers the question asked.
Yeah, thank you much. I think you gave some quite good indications already, even in numbers. So let's go to the second question, Kurt. This is definitely, I would say, for you as well, because about your networks. So the question is, where is location of IT and OT data lags in SNPN and PNI-NPN? So where is location of IT data lags?
Yeah. So I think if you look at the data lakes, so to speak, in the IT and OT, then we can clearly say that any OT data that is used via the 3GPP or 5G system, these user data are not stored and not provisioned within the 5G system. So clearly, if we talk about the OT data, they are in the actual applications which belong to the enterprise, not to the 5G system. And of course, the IT system, the 5G system, of course, collects its own data if it comes to usage, statistics, quality. Those data, of course, remain in the 5G system, and then they can be requested and queried by the IoT application to see what kind of quality and what kind of KPIs have been reached.
Thank you. Anything to add, Joachim, or?
No, I just like wanted to add like something about where the data lakes are, and people always think like, oh, it's just like we don't want to divulge this information because of course it's very business critical. What we're talking also about one of the most important performance categories for us for networks, which is dependability. So how good is the service available? So if you put information further away from production, then that is normally one that is not critical in terms of availability. And it could mean latency, but sometimes it means just like, is the connection still there? So enterprise data, I mean, this is like the same as for any operation. All data, for example, can be offshore, so to say, to a server somewhere else. But anything that is for the daily production stay close to the premise, and that is also because of this. You want to squeeze out every second of production that you can, and any second the factory is not producing, that is not a good second.
Okay, thank you. Yeah, definitely. So our next question, third one goes in a similar direction, but a little bit different. Is a question about experience, or what is our experience from 5G-ACIA, I would say, or from you. So it says, from your experience, are CSPs or mobile operators ready to offer PNI-NPN today? So are they ready already today to do this? Very
So of course, I
interesting.
mean, we both are not working for the CSPs, but I think we of course observe in the market. So I think there are already commercial offers out there on the market from various mobile network operators who provide PNI and PNs in whatever kind of formats. So I think we see that picking up quite heavily. I think we have many of these offers in the US, but also in Europe, in Asia. And I think this is a model that has been already on the market since quite a while. So the answer is, in short, yes.
Okay, good. So our experience, it's possible and available. Thank you. Then I'll go back because I have to look for the chat and the Q&A. There are different questions. So the next one, let me read through. If you speak about exposure, this refers to the capabilities of 5G NEF, or are you referring to something more than this?
Maybe I can take this one, Joachim. The next is then maybe for you. True. I mean, NEF is for sure one valid reference from 5G perspective. So from the 3GPP standards perspective, but we also have a layer on top of NEF that is the so-called seal, and that's yet another, let's say, simplification and another layer of exposure capabilities that would make life for enterprises easier to access these 5G capabilities. If you do the NEF way, you have to understand quite some details, how to use it, what these different APIs are giving you, and SEAL gives another abstraction layer for those enterprises who want to use a higher, less 3GPP focused interface. So NEF and SEAL is the one that I would refer to in this case. Yeah.
Okay. Then thank you. So there's more than just one solution to this, or option, let's say option. Maybe, I don't know, Joachim, I will read through if it's for you. The question is 5G-MPN, especially for factory. Do pose requirements also on aspects like access to spectrum and very likely new models for local regional spectrum? Access or shared spectrum might be required. So it's more command even. So it's about the spectrum side. Maybe you can give a comment on this.
So this is a statement, and I agree. But it's a little bit more complicated than people sometimes think. So it's not just like you have an SNPN and you have your own frequency. That's it. That's the only way you can go. There are countries, and there will be countries where there are no frequencies that really people can purchase, so license for from the government. That's not foreseen. And then you could say like, okay, but then we just like have as it is today, we just like have best effort. And the answer is no, because if you look at the capabilities of 4G and very much so also 5G, is that you can dedicate frequencies in a subband to, for example, the slices. So it's not just like a virtual thing, as in I have like priorities and all that, but I can also really in the run, I could, for example, say like, okay, this type of sub network can get this and this frequency. So it's definitely possible that if a operator decides to that this is necessary, can do this. Although it comes, of course, at the expense of the overall frequency then bandwidth available to the public, because we're still talking about public networks. So that's my perspective.
There was an add-on on this statement also. I would say a question was, can spectrum access, procurement and management be a stumbling block for 5G-ACIA and SNPN? That's related because came from the same.
Yes.
Yeah.
And spectrum access.
Yeah, I think one of us can answer. I think this spectrum access, of course, is an issue. So if it can be a stumbling block, it depends, of course, pretty much on the regulation in that country where you're operating in. Some countries have clearly set aside a piece of the spectrum that is to be used for non-mobile network operators, but for industrial enterprises. So there, of course, in those countries, this spectrum can be used. In many countries, the spectrum has not been set aside, so that, of course, is then a no option for the enterprise operating in those countries. So I think the answer is pretty much depending on which country in the world you're operating in, and also if you would like to spend effort on purchasing your own spectrum, or if you would like to reuse any spectrum for operators. So that's why it really depends on the country you're operating on.
Thank you. Yeah, just as an add-on, we have also a working group in 5G-ACIA where we're looking into those details, but only can be made available to members as a side note. Okay, going back to the chat, because there was also one more question. Okay, let me read through. How is SIM identify management dealt with, be it standalone or public network deployment, SPN versus PNI-NPN deployments? Are they differently catered for, please?
Maybe I can start quickly. I think the authentication mechanisms are, I would say, of course, if it comes to SIM cards, identical. I would just say identical between SNPNs and PNI-NPNs. In both cases, you will have to have an entity that produces these SIM cards for you, that you can distribute them into your devices. If it's a PNI-NPN, this is naturally done by the mobile network operators. He can provision then a bulk of 100 or 1,000 or 2,000 devices to you as an enterprise. If you go for an SNPN, then you can get these SIM cards again from the service provider who may operate it. And if you are operating this network yourself, you could get these SIM cards from that network supplier that in fact is delivering this network to you. In the case of SNPNs, there are also other mechanisms that could be applied where we do not use SIM cards, but we use other authentication mechanisms. But that would now basically spoil this time frame we have left. In principles, the principles of SIM management in both SNPN and PNI-NPN is similar. It might be different players who is basically providing the SIM card in the end.
Yeah, I mean,
please.
One minor
Please.
comment to me. It will not just be cards. So there is an evolution towards like not having like physical cards, but for example, on chip integration of them. That's of course also possible. But I'm also, this is sometimes more, you wish there were more offers out there for that. So, but that's definitely also coming. So, but I fully agree with the SIM is also an integral part of the public infrastructure. And also, especially if you, for example, want to have devices that then can roam into the provider network, let's say, for example, some outbound logistics or something like this, then of course the SIM cards have to be recognized by the operator of the PNI-NPN that does it. And so that's also another organizational reason why this is not just like always up to a factory who runs a network and says like, okay, let's just like get some off-the-shelf SIM cards and use them.
And then from the last question, I would say also from timing, I think Joachim is more again related to 3GPP. So let me read through. Also, 3GPP has delayed qualification of non-orthogonal multiple access, so NOMA, in 5G after results of NOMA study item tier 38.812. do you envision a role for NORMA in industrial 5G use cases, e.g. massive connectivity?
Yeah, I must say I'm not familiar with this study that has been referenced to, so I think we will have to take this offline because I do not know the exact content of the study and the status of it. So we will have to take this offline.
Yeah, ditto here.
Good. Yeah, then we are exact 1 hour later when we started. So big thank you again from my side to you, Joachim, Kurt. And for sure also to all the participants to ask those questions. And with this webinar, we will finish the second series. However, to make some promotion, we are already planning a third one, which gives a totally different view. However, you can, as said at the beginning, everything can be downloaded then. We will put this on our website. There are also more events as you see us, and then we hope you join us also at the events or the website, or even get a member. As you see here at the bottom, the webinar series is recorded and can be viewed, and there's also the QR codes for visit us also in LinkedIn. So we would be happy if this was fruitful for you, and as said, big thank you, applause to you, Kurt, Joachim.
Yeah, thanks for everybody joining. Much appreciated.
Yeah, so thank you. With this, we will close this.
Yeah, thank you. Bye.
Bye-bye.
Goodbye.